Good morning, good afternoon, and good evening. My name is Kevin Cloud A. Juang, and I'll be the voiceover for this video compilation. We are the Circuit Breakers group from 11 STEM Knowledge. And in this video compilation, there's going to be three lessons we're going to tackle, which are the LED, the buzzer, and the 7 segment. Now, this is the last one, which is LEDs. LEDs are usually an output device used in Arduino Uno. And these are the activities. Activity 1, blinking LED. This means the LED will turn on and then off 1 second at a time. Activity 2, fading LED. That means it could go from high to low or low to high. Activity 3, alternating blinking LED. That means there's two LEDs that blink one at a time alternatively. Activity 4, button controlled LED. When you press the button, it'll turn on. And activity 5, potentiometer control LED, where if you twist the potentiometer, it'll turn on the LED depending on the brightness of it. These are the materials needed for each activity below.
Blinking lights to, diba? Activity 1.
Activity 1. Okay. Activity 2.
Fading.
Yes, fading. Activity 3. Activity 3. Okay. Activity 5.
Ano?
In this lesson, we're going to talk about buzzers, and buzzers is another output device where it creates sound or beeping noises. And these are the activities. Activity 1, buzzer beep on button press. Very self-explanatory. Activity 2, melody player with a buzzer. By the help of coding, the buzzer will play a melody. Activity 3, SOS Morse code buzzer. In this activity, the buzzer will play an SOS Morse code. Activity 4, light sensitivity buzzer. With the reaction of light, depending how bright it is close to the light sensor, it'll play a buzzer. And activity 5, potentiometer buzzer. When twist, it depends on how loud the buzzer will play. These are the materials needed for each activity below. Sinilas nyo?
Patingin ka. Wala.
No, wala. Yan.
Activity 3.
Activity 3. Activity 3 to na? O 4? 4? Okay. Activity 4? In lesson 3, we're going to talk about 7 segment. 7 segment is an output device which displays number or a letter. Inside of a 7 segment display, there are 10 pins in total, and these are A, B, C, D, E, F, and G. Those correspond to the red lines inside of the display. The DP is the period inside of the display, and the middle pins are the G and D, or the ground pins. There are only 2 activities in 7 segment display, and these are display single digit on a 7 segment, and act number 2, display 0 to 9 sequentially. 0 to 9 sequentially meaning that it'll count them from 0 to 9 and repeat back all the way back to 0. These are the materials needed for each activity below. Activity 1. A.
Uy, i-upload dyan na.
Upload ba yun? 2, 3, 4, 5, 6, 7, 8, 9, 10.
Gumala!
3, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So in this task number 2, as you can see, I'm in tinkercad.com. It is a website where you could put your Arduino Uno or any type of Arduino with a breadboard, and you could modify it. You could put stuff in it like LEDs, the potentiometer like in this video over here. And as you can see, I'm creating a task what you call a dancing LED. I chose 5 LEDs with 5 different colors, and the additional component that I added is a potentiometer. That means that the potentiometer can control the speed of when the light blinks to the from left to right. It controls the delay of it basically. Initializing. So you can see, if you go all the way down, just wait for a bit, everything will be on because it's at 0 ms. That means everything is on, like really fast. And then once you put it here, it's gonna be half a second. There you go. See, and if you go all the way down, it's every 1 second. So, and it's the flow chart right here. With my potential value delay of 0 to 1,000 milliseconds. Was potentiometer turned? Was potentiometer turned? If it was, correspond to the delay with the potentiometer, and then if it wasn't, remain the same delay corresponding with the potentiometer. You just go down. LED blinks with the delay corresponding with the potentiometer. Light red and turn the remaining LEDs off. As the timer passes with the corresponding delay from the potentiometer. If it wasn't, you just wait. Just loop the code here until the time has passed. After the time has passed, turn off LED red, yellow, green, and blue. Light up orange here, and then you just repeat the same process for each LED until you go all the way back here. A button-controlled alarm system, and when you press the button, the buzzer and the LED will turn on for 5 seconds, and then after 5 seconds they will turn off until the button is pressed again. So this is what it's gonna look like. If you click it, and it'll stop, and that's just how it is. This is the code. There we go. The instance button pin 2 because it's connected to 2, buzzer pin to 9, LED pin to 8, same as the usual. I used ChatGPT for this to make this work. And as you can see, the step 1, detect button press. Step 2, detect release and start buzzer and LED. Step 3, keep buzzer and LED on for 5 seconds. That's basically it. It's the whole component. And for the flow chart, set pins as input output, initialize pins to low, read button state, is button press. If it wasn't, wait for button response. If yes, begin the 5-second countdown and turn on LED, turn on buzzer. Has 5 seconds passed? If it wasn't, continue buzzing and light LED up. And if it was, if the 5 seconds has passed, turn off buzzer and LED and wait for button response. In conclusion, working with Arduino Uno has helped me understand the basics of electronics and programming. Through controlling LEDs, buzzers, and 7-segment displays, we've learned how to use digital outputs, manage timing, and write simple yet effective code. Like for example, the LEDs. They taught us how to control lights and create patterns. Buzzers introduced sound feedback using the function like tone open parentheses. And with 7-segment displays, showed us how to display numbers by controlling multiple pins and using arrays. What we've learned so far is that we've gained skills in circuit building, coding with Arduino, and debugging simple electronic systems. These projects have improved my logical thinking and made programming feel more hands-on and more fun. Looking ahead from the future of this subject, we're very excited to move on to different kinds of components like sensors, communication modules, and more advanced projects like basic automation or simple robotics. We would like to also learn how to create a traffic light system based on what we watched from previous projects from different classes last year in STEM 11. This is just the start of exploring how software meets hardware.